Hi, hello, I'm Kiran Kumar from Nature of Physics and Art. Today we will discuss rolling motion and applications. See, first I will explain to the velocity, acceleration and next frictional force and coefficient frictional force of the rolling body on a inclined plane. Then after this video, step by step related numericals based on this concept. Okay, so first I wanted to find the velocity. For this, the body is releasing from the position A that have potential energy because of at a height h. Okay, here h is the height of the inclined plane and BC is the base and L is the length, that is AB is the length of the inclined plane. Okay, so the potential energy convert into what energy here? Kinetic energy. V is the final velocity. According to law of conservation of energy, here potential energy convert into kinetic energy. So law of conservation of energy. Okay, so that potential energy convert into kinetic energy. But here this is pure rolling motion. In pure rolling motion, that have the two type of kinetic energy. One is the translational kinetic energy, another one is the rotational kinetic energy. For this potential energy mgh, m is the mass of the rolling body, okay, which is equal to kinetic energy of translation plus kinetic energy of rotational. Okay, mgh, which is equal to kinetic energy of translational is 1 by 2 mv square plus kinetic energy of rotational is 1 by 2 I omega square. Okay, I is the moment of inertia, so here I is equal to mk square. Okay, and omega is the angular velocity, so here v is equal to r omega. R is the radius here, r is the radius, say. Okay, so from this equation omega, which is equal to v divided by r. Okay, so the values are replacing in the above equation, we will get the final velocity v is equal question mark. Okay, so for that here mgh, which is equal to 1 by 2 mv square plus 1 by 2 I value is mk square. Okay, omega value is v divided by r, that is v square divided by r square. Okay, so that continuation here m is common and cancel. Okay, so that gh, which is equal to 1 by 2 v square is common, so 1 plus, that is k square divided by r square. So from this equation 2gh, okay, divided by 1 plus k square divided by r square, which is equal to v square. So here velocity v, which is equal to root over 2gh divided by 1 plus k square divided by r square. Okay, so we can do one thing here. Theta is the angle of inclination, so here sine theta, which is equal to h divided by L, so h, which is equal to L sine theta, h, which is equal to L sine theta, we can replace in this equation. So second equation for the velocity, so v, which is equal root over, okay, 2g, h value is L sine theta divided by 1 plus k square divided by r square. This is the second formula, this is the first formula. Okay, these two represent the velocity of the rolling body on the inclined plane. After that, I will explain the acceleration and continuation frictional force and also coefficient of friction. And continuation now acceleration of the rolling body. For this, torque acting on a rolling body, so torque, which is equal to I alpha. Actually torque is equal to force into perpendicular distance. The force is here frictional force. Okay, and I alpha, I is the moment of inertia, r is the radius. So here we can take, this is the center and this is the radius. This is the radius. Okay, so torque is equal to force into perpendicular distance. Here frictional force and radius are mutually perpendicular, then sine theta is equal to 1. We can write directly torque is equal to, okay, so that Fr, continuation I alpha value we have to replace from this equation. So the rate of change of velocity is called acceleration, which is equal to r into alpha. Rate of change of linear velocity is called linear acceleration. Rate of change of angular velocity is called angular acceleration. And from this equation here, alpha which is equal to a divided by r. So alpha value here replacing, that is a divided by r. Okay, so from this equation we can write frictional force F which is equal to I into A divided by R into R is R square, is taken as equation number 1. Okay, so M is the mass of the rolling body. Mg resolve into two components. So here Mg acting downward direction, this is Mg. So Mg is acting downward direction, then that is resolve into two components. So this is the normal reaction and this is taken as here mg cos theta. So this is making an angle theta, so then mg cos theta. Okay, this is mg cos theta and this is the normal reaction. So here normal reaction is balanced by the mg cos theta. Okay, so this is the normal reaction which is balanced by the mg cos theta. Both are equal in magnitude, opposite in direction. And next mg sin theta is the vertical component, that is, this is the mg, okay, sin theta, mg sin theta. Okay, so then continuation we have to discuss here. M mass moving with an acceleration a, then we can apply the Newton's laws, that is Newton's second law. Especially here M mass moving with an acceleration ma is the resultant force ma, which is equal to, towards resultant force is mg sin theta. Okay, away from the resultant force is frictional force. Always frictional force is opposite to the direction of motion of the body. Here again rewriting mg, not appearing clearly, so this is mg. Okay, so now frictional force is replacing in this equation, then we can write step by step here ma, which is equal to mg sin theta minus I into a divided by r square. This value is from RHS side to LHS side, then acceleration is common, m plus a divided by r square, and remaining value is mg sin theta. So here acceleration, first equation is mg sin theta divided by m plus, here I value is moment of inertia. Okay, sorry for the mistake, acceleration is common, so then I divided by r square. So this is the, okay, equation number 2 for the acceleration. So in this equation I value we can replace, then we will get the second equation for the acceleration. So we can write continuation acceleration a, which is equal to here mg sin theta divided by, okay, so here m plus mk square divided by here r square. Here m value is common and cancel, so we can write another equation for the acceleration a, which is equal to g sin theta divided by 1 plus, Okay, m is common and cancel in numerator and also denominator. 1 plus k square divided by r square. This is the second equation. So continuation we got taken as this is equation number 3. This is the second equation for the acceleration. Okay. Now continuation frictional force after the acceleration. For frictional force already we got equation 1, that is F is equal to moment of inertia into acceleration divided by r square. R is the radius of rolling body. Here I is equal to mk square. Okay, so k is the radius of gyration. Okay, and a is the acceleration of the rolling body. Both values replacing in this equation, we will get the frictional force. So F, which is equal to I value is here mk square. Okay, a value is g sine theta divided by 1 plus k square divided by r square. Okay, and whole divided by here what is there, r square. Okay, try to understand. Here we can do one thing, modifying this equation. Try to understand that step. Okay, frictional force F, which is equal to numerator is mg, m into g sine theta divided by here r square divided by k square. K from numerator to denominator, that is r square divided by k square. Here 1 plus here remaining value is k square divided by r square. This value is multiplied. Here r square, k square is get cancelled. Okay, so here 1 into r square divided by k square. Okay, so that frictional force F, which is equal to mg sine theta divided by that 1 plus, okay, so r square divided by k square, or we can write r square divided by k square plus 1. Anyhow result is same only. Okay, so this is the equation for the frictional force, and continuation we can find the coefficient of friction. So here coefficient of frictional force constant, coefficient of friction, simply coefficient of friction, so that is indicated letter mu. Okay, so coefficient of friction mu we have to find from this equation. This is taken as equation number 4. Okay, from equation 4, before going to that frictional force F, which is equal to mu into n. So frictional force F, which is equal to mu into normal reaction, so that mg cos theta. Here normal reaction n, which is equal to mg cos theta. Both are equal in magnitude, opposite in direction. So that the value is replacing here. So the mu mg cos theta, which is equal to just f value replaced here, and remaining value is same only, mg sine theta divided by 1 plus r square divided by k square. Okay, here get cancelled, mg is get cancelled, here mg is get cancelled, and remaining we wanted to find mu, that is coefficient of friction, which is equal to sine theta by cos theta is tan theta divided by 1 plus r square divided by k square. This is the equation number 5. This represent the coefficient of friction. Okay, I will continue next video with numericals based on the velocity, acceleration, frictional force and coefficient of friction. Thank you.